Hey guys, this Houdini project file is available on GoRoad. You can watch the full tutorial for free here on YouTube. And grab the complete file to boost your studies. The link is in the description. Welcome to the PS5 FX course. This course is divided into 3 videos. The first covers preparation, where we set up the scene and assets. The second focuses on simulation, where we create the dynamic effects in Vellum Grains. And the third is all about rendering, where we finalize everything with light and outputs in Redshift. Let's get started. Let's create a subnet. Let's rename to PS5, joystick add, change the color to blue. Let's dive inside, create a geometry node, rename this to geo symbols. Let's dive inside. We are going to use that text right here to convert this to geometry and extrude. Let's do that. Let's load the image using trace node. Here. Let's split the symbols. Blast. Keep it triangle. Create another blast. Keep circle. Another blast. Keep cross. And the last one, keep it square. Let's work in the triangle first. Delete non-selected. Keep circle. Delete non-selected. Keep cross. Delete non-selected. And keep square. Delete non-selected. Let's move to the center, match size. And we can rotate this a little bit, rotating the Z. No. Let's rotate the X. Okay. Let's clean up a little bit the geometry. Actually, you can delete the inside piece and make extrude inset in extrusion. Delete small parts again. Just extract the largest piece. Let's resample this. It's working, 3 points. Facet. Removing line points. Extrude polygon and make it this inset. Okay. And disable the output front. Create a poly extrude again. And give a little height, like this, and fill the output back. Let's create a bevel. and create a checkpoint. Auto triangle. Adjust a little bit of the bevel. Okay, is enough. And that is the triangle. Create a normal. Polygons. Okay. Let's go and do the same with the circle. Create a match size. Labs delete small parts just to keep outside the larger geometry. Let's resample. Okay, it's fine. Let's copy all these nodes here. Do the same operation with the poly extrusion. Actually, we don't need this facet. Okay. And we don't need the extrusion here. Poly extrusion. We don't need the bevel. Actually, we can change the bevel here. And exclusion, ignore flat edges. Like this. And create a checkpoint. Alt circle. Change the color to black. Go to the cross. Copy all these nodes to see if it's working. Delete small parts we don't need. Let's resample. Actually, resample. We need to make facet. Remove inline points. It's okay, perfect. And extrusion. We don't need the extrusion by inset, just the extrusion in the height. A little bevel. Normals. And a checkpoint. Alt cross. Change the color to black. And the last one is the square. We can do the same operation. Let's copy these nodes here. Match size. Delete small parts. Okay. Resample. Actually, use a facet to remove the line points. Okay. Extrusion inset. I think there's 2 points here. Yes, we need to fuse this operation here. Poly extrude the same extrusion from here. Copy. Patch relative reference. Extrusion by height. Little bevel. Normals. And rename to square. Let's create a name. It's triangle. Create another name. Circle. Create another name. Cross. And the last name is square. Let's merge to see if it's working. Create another checkpoint for previous out symbols. This is all the symbols. Let's translate this to see if it's working. The symbol is working. Let's fix the X. There's a problem here in the geometry. I think we need to fuse. There's a lot of overlapping points here. Let's fuse first before the extrusion. And now it's working. If we don't need the bevel, we can disable here. Let's enable a little control. Just to enable and disable the bevel, because if you are going to instance this to 1,000,000 particles, maybe we don't need the bevel, just the low poly resolution of the geometry. Let's control this. Change the color to yellow. Create an attribute here in parameter interface. Integer. Hide these parameters. Change the name of these parameters to bevel. Enable bevel. Change this to toggle. For each bevel, we can enable, disable these nodes just by creating a switch here. Connect here again to the first input. If we need to enable the bevel, just copy this parameter, copy parameter, paste here, relative reference, and do the same for the other symbols. Copy this, paste here, change the order. If you want to change the order of the connections, you just use Shift-R to change the order of the connections. Paste again, Shift-R, paste again here, change the order of connections, Shift-R. If at the rendering time we are going to need to bevel this geometry, just can enable here. Okay. Let's import our joystick now. Let's create a geometry node. Rename this to joystick. Asset. Color to green. Let's dive inside. Create a lambic node. This joystick is modeled in Blender. I created this in Blender. Let's adjust each piece here have a name attributes This attribute should be organized because we are going to apply the shaders per attribute instead of texture. Using the whole geometry, we are going to apply the shaders by the name of the object. Let's sanitize these attributes names here. Create a vex, pointer angle, rename this to vex name, change here to primitives, and create a script line here. S at name equals split S at path by slash. Here just as path by slash and grab the first value of that. And we have now the name attribute and the path attribute. We can delete the path. Delete path attribute, we don't need anymore. Create unpack node. Transfer all the attributes to the geometry. Create a checkpoint here. Ref joystick in. We don't need these normal attributes. We just need to keep the UVs. Some buttons, for example, there's a letter in each button. These buttons have the UV textures to apply the letter. Delete the N, the normals. Let's scale this to Houdini using a transform. Rename to scale to Houdini. The scale should be 1.15 and rotation in X minus 90. Minus 90 in X and 90 in Z. Almost aligned to the ground. Let's create another transform just for adjust the rotation. Rename this to adjust rotation and rotate in X minus 24. Create another checkpoint here. Alt joystick. Here you can adjust a little bit of the rotation like 15, minus 15. That's okay. And create a color here just for play-based visualization. Like a dark gray. Okay. And you can disable the UVs here. Or just delete the UVs. For the play blast, we don't need to see the checker of the texture. After the Alt joystick, we are going to delete the UVs. We don't need for visualization. Now you go up there and create another geometry. Rename this to joystick anim. Color to green. And they are going to reference this guy here in the animation node. Let's dive inside, create object merge, paste here, relative path. Let's create a transform, rename to animate joystick, create a checkpoint, alt joystick, anim, change the color to black, and color for flipbooks should be a dark gray as well. Change the color to animate the joystick for a meaningful color like yellow, and let's animate. First, we are going to change the timeline here to 30 FPS, apply FPS, and 220 frames. That's the time frame, the timeline of our frames. If you need some frames, you can change this value later. In the animation here, let's see by the side. I move down a little bit the joystick. Until it's below the ground. Like this. Minus 1.2 in Y. Rotation around 88. Let's go back here to Alt Joystick and change the rotation here. In the rotation, we are going to change here to minus 24 again. And create another translate here. Final rotation. Adjust this frame around 8. Just final touch. Disable this node here. Enable this node. That's the first frame. Let's apply the keyframe here. Around the frame 60, 55, 56. Let's move a little bit up. Let's rotate our gizmo here for aligning to the word. $56, up there a little bit. Like minus, like 0.078 keyframe. In the frame 64, move more a little bit, like 0.37. A final push for the animation. Yeah, just a simple animation translating Y, no complicated. Let's create another node here, geometry. And let's create a collider for this joystick to interact with the Vellum Grain simulations. Change the color to green and rename this to joystick collider. You can group these nodes here. Rename to joystick. Color to black. Disable these nodes, we don't need to see it now. Let's create a collider for this, the joystick. First, let's copy this node here, joystick anim. Go to this node, create object merge. paste the path here, and apply to relative path. Let's convert this to VDB to make a uniform collider without the empty space inside or disconnected pieces. We need like a convex whole shell for the entire joystick to collide properly with the grains, the simulation. Actually, instead of the animated version, we are going to change this to the gel joystick asset out joystick. For this collider to work properly, we need to fill this piece here with polyfill. Let's do that. Let's create a split. Select this little piece here. Actually, by the name. Create a polyfill. Okay. And merge back with the original geometry. Let's subdivide the entire geometry with one level of subdivision. Let's scatter points on the surface. Let's disable these relax iterations and increase the total points to around 2 million. 2 million points. Let's create a VDB from particles. Let's see the result. The PSK is too high. Let's decrease here points radius scale to around 0.01 and the voxel size here to 0.005. 0.005. Okay. Let's create a VDB smooth. VDB smooth SDF. Sorry, I forgot to disable this maximum point limit here. Just disable this attribute to avoid see the small gaps in the points. Okay, now it's working. Let's convert back to this to geometry. Convert VDB to geometry. In the adaptivity, change here to 0.1. We don't need so many polygons in the geometry. And you can delete the inside piece because there's a layer here. If you clip this geometry, we can see the inside the geometry. There's a shell inside. We don't need inside parts, just outside. Let's delete the clip. Create a blast node. Blast inside. Change here just to connect the geometry. And delete and non-select. We don't need this inside piece, we just need the outside, the connected shell. We convert this back to VDB. VDB from polygons. Voxel size around 0.3. Create a VDB reshape. VDB reshape SDF. Just to shrink a little bit. Erode 0.5. You can see the shrinking of the geometry. Convert back to geometry. Let's see smooth shaded. Let's create attribute delete. To remove all the attributes we don't need. Let's save a cache. File cache to avoid the processing of the VDB network here. Rename this to cache. Joystick collider. Just one frame we need. Create a checkpoint here. Alt. Joystick. Collider. Static. We can copy the animation nodes here from the joystick and in. Let's copy this node. Go back to the collider and paste here. And we have the animated the collider for the simulation. And create another checkpoint for animate the collider. Alt, joystick, collider, and in. Change the color to black. Let's organize our network. Let's create some cameras here. Camera, shot 1. Let's align this camera in position. And adjust the values. Here is minus 1.19. 11 here. 0 here. 0 here. Minus 83 here. Minus 83 here. Let's adjust the position. View 35 focal length. Aperture 38. We can zero out here. Zero out this value. Let's create another camera, copy this camera, shot 2, and create a lookat for the camera 2, cont 2. Let's set the camera 2. First we need to apply the lookat. To apply the lookat, we go to constraint shelf here. Select the lookat, select the camera, click lookat, and select the no. Apply enter. Let's see if it's working. Let's change the locate to see if the cameras work. Yes. If I change the locate position, the camera is working. Now we need to animate the second camera. Let's animate the position. Here there's start position. At the frame 100, we zoom out a little bit. At the frame 156, we will rotate back to the almost the top camera version. In the last frame, we approach the zoom a little bit. That's the second camera animation. You can change the zoom out not to so close, like this. We can see we can create another camera too. Just copy this camera too in the locate. Ctrl C, Ctrl V. Apply the blocks. Let's say the camera 3. Let's move our locate. At the frame 55, actually we need to delete some keyframes from this new camera here. Let's delete all the keyframes. At the frame 55, let's create our first keyframe. At the frame 108, let's zoom in a little bit. Like this. Let's create another copy of the camera 3, Ctrl C, Ctrl V, and animate the last camera. Let's organize our camera checkbox. The last camera, camera 4, is just a static camera, just for test renders. You can delete the keyframe of the camera 4 and adjust the position like this. That's the position of the camera 4. That's our 4 camera animations here.